Linear combination and spanning set. Here is a very interesting question for you. Can every vector in xy plane be written as a linear combination of vector u, which is 1, 4, and vector v, which is -2, 5? Now, second part of this question is, write the vector w, which is -5, 6, 7, and -6, 6, 9, in terms of u and v. Does w terminate on the line through the endpoints of u and v? Explain. So that is the kind of question which we have, and the last part of it is kind of tricky. So let's try to solve this. Now the first part is, can every vector in xy plane be written as a linear combination of these two vectors? So the answer should be yes. Now why yes? You have to write two critical things about this. One, they are non-zero vectors. So I need you to mention both the things. And second, they are not collinear. So we say non-collinear. So that is why they both represent a spanning set. And every vector in xy plane can be written as a linear combination of these two vectors. Now, why are they non-collinear? Let us see, if I multiply this by -2, I get a vector -2, -8, not -2 and 5, right? So the scalar multiple doesn't work here. So they are not collinear. Now part B is, write the vector w in terms of u and v. Now since all the vectors can span using this spanning set, so the question here is, we are given one vector w which could be written as a linear combination of these two. So let's do it. So that means that vector w should be written as a times u plus b times v, where a and b are real numbers. So when we say write the vector w in terms of u and v, then we're trying to figure out how a linear combination of u and v can result into w, right? So that is what it is. So I'll use column matrix to do this. So what is w? W is -567 and -669. And we can write this as a times u, which is 1 and 4, plus b times v, which is -2 and 5. Correct? Now from here we can get two equations. So one equation is -567 equals to a minus 2b, and the second one is -669 equals to 4a plus 5b. Now you can see we have two equations and two variables a and b. Let's call this as equation 1 and this as equation 2. Now solving these two equations, we should be in a position to figure out what a and b are, right? So I can now do it on the right side of the page. Now we have two equations and two unknowns, so we can find them by substitution or elimination method. So from here we can say a is equals to what? So from equation 1 we can write a is equal to 2b minus 567. Now if I substitute this value of a in equation 2, then I can find b, right? So let me call this, okay, let it be so, as equation 3. Now from equation 3 we can solve for a. So let's go here this time. So we get a equals to 2b minus 567. So we'll substitute 3 in equation 2 to solve for b, right? So let's do that part and then see what we get. So we have -669 equals to 4 times 2b minus 567 plus 5b. Now let's open this, bring the constants to one side. 8b, and this is 4 times 4 times, so that is minus 4 times 7, 28, 2, 60, 24, 26, and 22, plus 5b. So we have 3b here, 8b minus 5b, and this term comes on the side, so we get 669 plus 2268. So 3b is equal to, so let's use a calculator and figure out 2268 minus 669, that gives us 1599. Well, 8b plus 5b is 13b. Yes, 13b, not 3b. So this is 1599, and so b is equals to 1599 divided by 13. So divided by 13 gives us 123. So we get a value of b as 123. So we found one of the scalar multiple, which was 123. Now from equation 3 we can find what a is. So a is equals to 2 times b, which is 123, minus 567. So that gives us 2 times 123 minus 567. So that gives us minus 321. So we can find both a and b. You should know this is always unique, and therefore we can now write down w in terms of u and v. So w, vector w, is equals to a times, which is minus 321 u, plus b times, which is 123 v. So that is how we can write w in terms of u and v. I hope you get all the steps that should help you to solve similar questions. Thank you and all the best.